Welcome to the Spacecraft Assembly Facility at NASA's Jet Propulsion Laboratory. Behind us is the clean room where you can see NASA's Europa Clipper spacecraft. Europa is the name of one of Jupiter's moons. It's just a little smaller than Earth's moon, but previous missions have shown strong evidence of an ocean of liquid water beneath its icy crust, and the Europa Clipper is going to investigate. So let's talk to some experts about the mission. Joining us today is Europa Project Staff Scientist Cynthia Phillips and Europa Clipper Project Systems Engineer Jennifer Dooley. Thanks for joining us. They'll be talking to us for the next half hour or so, answering your questions. So if you have a question you'd like to ask, drop in the chat below and we'll get to as many as we can. So to get us started, Cynthia, could you tell us more about Europa and why scientists want to investigate this area?
Sure, Raquel, and thanks so much, and thanks to our audience for joining us today. So, as Raquel said, Europa is a moon of Jupiter. It's about the same size as Earth's moon, but it looks completely different. Instead of having a surface that's covered with rock and craters like our own moon, the surface of Europa instead is covered with ice. Has a thick layer of ice at the surface that's filled with cracks and ridges, and scientists are pretty sure that under that ice layer is a global ocean layer of liquid water. And this ocean could have more water than all of Earth's oceans combined. And so because of that, scientists think that Europa is one of the best places to look for life in our solar system beyond the Earth. And the Europa Clipper spacecraft is going to take the first step in going to Europa to assess the habitability of Europa. So Europa Clipper isn't going to look for life directly. What it's going to do is it's going to look for places below Europa's surface that we think could support life as we know it.
This sounds like an exciting mission. And Jennifer, can you tell us more about the spacecraft that we see behind us?
Absolutely. So right behind me, you can see the propulsion module. This is the main structure for the spacecraft. And if you can see the red covers, those are protecting some of our propulsion components. We also have a vault, which is a large container that provides shielding for some of the electronics and other sensitive components that helps shield from the radiation environment. And then after we have assembled all of that, that vault goes on top of the propulsion module. And as we continue with the assembly of the spacecraft, eventually we'll bring in the solar arrays and mount those to the propulsion module as well. And so you can see, you know, if you saw the image that was projected a little while ago, the scale of that, right? This is the very large spacecraft.
You can really see it behind us. And there is some action going on behind us. Can you let us know maybe what is going on right now?
Well, so right now we've got the crane that the team is using to start to move some components and check out the lifting fixtures that we have and slings to ensure everything's safe before we do any move of hardware. We also have work going on which is a little bit less visible, but over on the vault we have several of the instruments that have been installed and are starting to go through their functional testing. And today we're testing the ultraviolet spectrograph. And the tests that are going on today are going to be checks of the thermal functional, so heaters and temperature sensors. They're going to be moving files to the instrument to ensure that if we need to, we're able to update the software while we're in flight. And then they've also rotated the vault from where it was yesterday so that they'll be able to check deployment of the cover and the door. So that's all going on today.
A lot of exciting stuff happening right now. And we're seeing it live right now. And for everyone just joining, we are in a space where the Europa Clipper spacecraft is being assembled ahead of its scheduled 2024 launch. So over the next several months, you can keep track of its progress with our live cam on our YouTube channel. And let's actually take a look at that feed right now. You can get a quick preview of it. You know, this feed runs live 24/7. So be sure to bookmark it or save it so you can check it out whenever you have free time. And I have another question for you, Cynthia. You know, Europa, we're about to get a close look at Europa with a different mission soon, correct?
That's right. So the last time that we saw Europa was up close was with the Galileo spacecraft. This spacecraft traveled to the Jupiter system in the late 1990s, and it orbited Jupiter with multiple close flybys of Europa and the other large satellites from 1995 until about 2003. But since 2003, we haven't had any close-up pictures that have been taken of Europa. We've had a few distant pictures that were taken by other spacecraft as they passed by the Jupiter system on their way to the far reaches of the outer solar system, such as the Cassini spacecraft and then later on the New Horizons spacecraft. But we're really excited because tomorrow morning, our time here in California, the Juno spacecraft, which has been in orbit around Jupiter for the last couple years, Juno is going to have its first close flyby of Europa. And so we're really excited to get to see a few new pictures of Europa for the first time in almost 20 years.
That's fantastic. I think 2 decades now. Will people at home watching be able to see it?
So you won't be able to see the flyby yourself. But the pictures and the other observations that will be taken by the spacecraft will be downloaded tomorrow, so this is Thursday, and we expect to see the first pictures released within the first day or two. And then the scientists will take a little bit longer to process all of the information from some of the other instruments on the Juno spacecraft. And so we should expect to see more results from that come out.
Very cool. And what about Jupiter? Like, could you see it at home right now since it's so close?
That's right. So this is a really exciting time, actually, because Jupiter's at what's called opposition. And opposition is when the alignment of the planets is such that Jupiter is at about as close as it ever gets to the Earth. And so this means that Jupiter will appear like a really, really bright star in the night sky. And you can actually go out and see Jupiter yourself. With just your eyeball, if you look up, you'll see this really bright star. But with a cell phone, with night mode, or with just a simple pair of binoculars, if you look up, you can actually see some of the moons of Jupiter. So you could put your eyeballs on Europa tomorrow at about the same time that the Juno spacecraft is going to be flying past it in the Jupiter system. And I just think that's so cool.
Very much so. I really want to get a pair of binoculars right now that you mentioned it. So let's kind of bring it back to the room right now. And Jennifer, the Europa Clipper is behind us. Can you tell us about some of the spacecraft instruments that we can see right now in our view?
Yeah, absolutely. So we mentioned the ultraviolet spectrograph earlier. So that is an instrument that is going to take spectrum in the ultraviolet range, and that gives us a fingerprint, essentially. Lets us look for things like oxygen or carbon dioxide or simple organics. So that's a really exciting instrument. It's also one of the instruments that we would, if we were lucky enough to come across a plume, we would want to interrogate it with that. That would let us look at some of the material coming directly from the ocean, which is, of course, the environment that we're very interested in understanding its habitability. Other instruments on the spacecraft right now, very close to where the UVS is, include our thermal imager, which is going to let us look very carefully for little temperature variations that might indicate thinner ice or younger material. It will also let us interrogate the surface. So is it hard packed solid ice? Is it more fluffy, grainy type of material? And that's sort of an interesting feature of it and could feed into decisions for later about where you might want to go to do our next kinds of missions that go to Europa. And then another one is the wide-angle camera, and that's going to be just a workhorse, right? We want to map and get color images of as much of Europa as we can, and I think that together with its narrow-angle camera sibling is going to get us over 90% of the surface.
Thanks for that breakdown. Now, if you're tuning in, we're about to get to your questions. We'll answer as many as we can, so please drop them in the chat below. Joining us right now is Europa Project staff scientist Cynthia Phillips and Europa Clipper Project Systems Engineer Jennifer Dooley. And I actually want to talk about your roles right now. So, Jennifer, can you tell us more about what your role entails?
So my responsibility is ensuring the technical integrity of the mission and that the mission accomplishes its essential function, which is getting all of the great observations to pass to our science team. And really a big part of that is, you know, we can talk about the different instruments and the different subsystems, and we design up front, we give everybody their marching orders, what to make, and then it comes in together, and one of our jobs is to make sure that all of those pieces play well together. And again, we're able to accomplish the ultimate function, right? That we haven't lost the forest for the trees.
Thanks, Jennifer. And now, Cynthia, can you tell us how you are part of this mission as well?
Sure. So I work as part of the Project Science Group. And basically, on Europa Clipper, we have one project scientist who's kind of the one who's in charge of making sure that all of Europa Clipper's complex instruments work together to accomplish all of the science goals that we have, the goals and objectives for this mission. And as part of the Project Science Group, so we have our project scientist, Bob Papalardo, and then we have the principal investigator of each of the instrument teams that we talked about. And then there's over 100 scientists who are part of those different instrument teams who work as part of the whole science team for this mission. And so as part of the project science team, I basically just help to make sure that everything is coordinated between the folks who are building our spacecraft, the folks who are building our instruments, and then the scientists who eventually are going to make the plans for how we use those instruments to observe Europa.
Great, thank you. Thank you both for letting us know your roles. And now it's time to get to viewer questions. I think that was really helpful. So Colin on Twitter asks, how will this upcoming Juno flyby help the Europa Clipper team?
That's a great question. So when the Juno spacecraft goes by, you know, as I said, we haven't seen Europa's surface for almost 20 years. So, you know, we know Europa's still there, right? Mm-hmm. It hasn't gone anywhere, but it's possible that something could look different on the surface. And one of the things we've been really excited about that's happened in those 20 years since the Galileo spacecraft ended its mission is that we started seeing evidence that maybe there's plumes erupting from Europa. We don't know for sure that they're there, but we've seen some kind of tantalizing evidence, both from reanalysis of some of our old spacecraft data, but also from observations taken by Earth-based observatories like the Hubble Space Telescope. And so one of the things that Juno will be able to do is to see whether is there any evidence that something's changed on Europa? Is there something erupting from Europa? Or even, is there a place on Europa that looks warmer than we would expect it to look? And so we're going to be looking at the data from the Juno flyby really carefully to help us plan for what we might see with Europa Clipper.
It'll be really exciting to see those images coming very, very soon. So this is a question for Jennifer. David on Twitter asks, what does the future hold for the second spacecraft to the left of you on the clean room floor? So he must have seen it when there was a wider view of the clean room.
Right, so I don't think you can see it now, but what you would see if you were standing where I am in the viewing gallery behind me is essentially a clone of the propulsion module that we were kind of looking at earlier that has the red shields, you know, at different places around, minus those shields. And essentially the purpose of that is it's a test article. So we do a lot of testing on the hardware that we actually send on our missions, but we usually build other copies of them of various fidelities for different purposes, and a lot of that's figuring out how to make sure it works, figuring out that it works as it's designed to, that has the margins to make sure that it's going to be successful and not fail, because once you launch it, you can't get it back. And so the one off to my right is actually designed for mechanical testing. And they do that to make sure that our big structure you know, can handle all of the loads that it goes under through its test and through the launch and the rest of its mission. So those are very important articles for us, more critical hardware, even though it doesn't actually leave our planet.
It's very interesting to see the clone right next to it as well, both in the clean room. And next up, we have Alex on Twitter who asks, is Europa literally cool, as in cold?
That's a great question. And yeah, the surface of Europa is not only cool, it is freezing. The surface temperature is about 100 Kelvin. So that is way below zero. So while we know that the surface is covered with ice, that ice is really, really hard. It's kind of hard as a rock. So it'd be really hard to say go ice skating on the surface of Europa, unfortunately.
Well, it's kind of nice to know that it's cool in both senses. It's cool and cool. So On Fire 1543 on YouTube asks, after it finishes its goals for Europa, would it be able to explore other moons of Jupiter?
Well, that's a good question. We would love to be able to send the Europa Clipper spacecraft to visit other moons, but its main goal is to investigate Europa. So right now we're just really focused on the main mission of Europa Clipper, where it's going to have about 50 close flybys of Europa. But before it gets to that point, when it first reaches the Jupiter system, we have to go past some of the other moons to help tweak our orbit around to actually get to that orbit where we can fly close by Europa multiple times. So we will have a couple flybys of Ganymede and Callisto, and so, you know, I would very much like to turn on the cameras and do a little calibration at those moons, but we'll see what we're able to do once we get there.
Well, that'd be nice to see. We have Emma on LinkedIn who asks, this is for you, Jennifer, what instrumentation or functionality of the Europa Clipper spacecraft are you most excited about?
Oh, that's a good one. Oh, there's so many great instruments to choose from. We love all of our children. And really what's amazing about the payload is how well it complements, you know, all of the different investigations. So one of the really exciting instruments is actually Reason. It's a radar. It's an ice-penetrating radar, and that is going to we use that when we're very close to Europa, and it's going to help us understand how thick the ice is, whether or not there are subsurface lakes, you know, other things like that. So that's a fantastic instrument. We have a magnetometer, Europa Clipper magnetometer, and that really looks at the induced magnetic field. And that's how we know, magnetometry is how we collected the early evidence that there is an ocean. And so coming back to that kind of an instrument is really exciting as well. And that would help us understand salinity and the depth of the ocean. I'm looking at Cynthia to make sure I've got this all right. You know, it's I know, I'm adjacent. But I have to admit, we have so many great investigations. There's a mass spectrometer that's going to look for, you know, organics, right? That's all that really interesting stuff. That leads to, you know, when you're looking for habitability, you're looking for energy, chemistry, and that helps us get to instability, right? And so these all get to those. But the pictures from the Europa imaging system, they're going to be amazing. And I expect that we're all going to wallpaper our houses, you know, with images of Europa. It's going to be fantastic.
That's a great answer.
So
That's a great answer. I was going to say, like,
but the camera's the best.
And speaking of, Ezra on YouTube asks, what sensors/cameras will be used on Europa Clipper? Jennifer, would you like to take that?
What cameras? Mm-hmm. Let's see. I think we're the narrow angle and wide angle cameras from ICE, they use CMOS detectors, which is the same kind of technology that I think you have in your cell phone camera. And so, you know, it just goes to show those are going everywhere, right? Yeah, so those are, one is a refracting telescope where the light goes in and gets focused, and another one is reflecting, and one of them has a gimbal, so you can move it around and you know, track different specific areas where you want to get high resolution, and also lets us do a stereo, so you can get some 3D view of what the surface looks like. Again, that's going to be very interesting for reconnaissance and for understanding the geology.
Lots of angles with those cameras. And let's see, we have Richard on LinkedIn who asks, how are you planning the launch? Like, when are you planning the launch, and how long do you think the flight will be?
That's a good question. So right now, our planned launch date is in October of 2024. So you don't have to make your travel plans quite yet, but you know, I know where I'm going to be in October of 24, which is in Florida at Cape Kennedy, watching this thing go. I can't wait. And then it takes a long time to get to Jupiter. We're actually going to swing past Mars first. So we'll go launch from the Earth, we'll go by Mars, and we'll do a Mars gravity assist. So we'll steal a little bit of energy from Mars, basically, of momentum. will go past the Earth again, and then we'll finally have enough energy built up to swing all the way out to the outer solar system to get to Jupiter. So it'll take about 6 years before we get to Jupiter. So 2030 is about when we arrive in the Jupiter system.
Start planning out for 2030 now too. And Evelyn on YouTube asks, if there are habitable conditions underneath the surface, what will be the next step? What instruments will determine habitable conditions, and how does it work?
So Europa Clipper is an amazing spacecraft, and it's going to study Europa from space. So Europa Clipper isn't going to actually land on Europa or touch the surface. It will be able, though, to measure some of the material that's thrown off of Europa's surface through very small meteorite impacts and through charged particle impacts. This material, in the form of dust and gas, gets thrown into space, and it'll actually be sampled directly by two of the instruments on Europa Clipper that Jennifer already mentioned. The SUDA instrument is a dust analyzer, and then the mass specs instrument is a gas analyzer. So those two instruments will be able to kind of give us our first taste of Europa's composition. But if we really want to study whether or not there's life on Europa, we're going to have to touch the surface. And so I'm hoping that in the future, especially once we see all those amazing pictures and the other information that we get from Europa Clipper, that we'll be able to have a new mission that will actually land on the surface of Europa, scoop up some of that surface material, and study it on board the spacecraft to look for signs of biosignatures. So maybe compounds or other evidence that might suggest that maybe there is life there. So that's off in the future. Europa Clipper is kind of the first step in a journey that hopefully will bring us to understanding really the role of life in the solar system. I can't wait.
And I actually met Cynthia working on that concept.
Working on the Europa lander concept.
Really?
Yeah.
So you two go
We go way back.
Yeah.
That's very exciting. And we actually had a really good follow-up question from Victoria on LinkedIn who wants to know, are we looking for specific elements, molecules, or temperatures?
Yeah, that's a really good question. So when we're looking for materials with Europa Clipper, we're going to be looking for kind of simple materials. So we know that there's things like the basic compounds like carbon, oxygen, nitrogen, hydrogen, phosphorus, so sulfur. So some of these materials we've already detected on Europa's surface using both the instruments on the Galileo spacecraft as well as ground-based telescopes that can actually analyze the composition of Europa's surface. And so Europa Clipper, using those direct instruments that I just talked about, SUDA and mass specs, it'll be able to look for even more complicated materials. So, maybe some more complex carbon compounds, maybe some sulfur compounds that are thrown off the surface and then are detected directly by these instruments. And so while, we're not expecting to get smacked in the face with a fish that gets thrown off of Europa, we do think that we can find some really great information about the details of the chemistry that's going on either at the surface of Europa, or if there turn out to be plumes on Europa, Europa Clipper will actually be able to fly through those plumes. And if that's the case, it'll be able to get a much fresher, bigger sample of material that comes from the subsurface. Maybe from an inclusion of liquid that's within the ice shell, maybe even from the ocean, depending on how kind of the plumbing works inside of Europa. So that would be really fascinating.
You mentioned oceans, and Nancy on LinkedIn is asking, why do we think there are oceans below the ice?
So this is a great detective story. Basically, with the Galileo mission, we knew even before Galileo got there that Europa's surface looked different. We knew it was really bright. We knew it was covered with ice. We could tell even from Earth-based telescopes that Europa's surface had a compositional signature, a spectral signature that tells us that there was ice at the surface. So there's a big difference, though, between solid ice, frozen, and then liquid water. And so the Galileo spacecraft got to the Jupiter system in the 1990s. It took all these pictures that showed places on the surface where the ice was cracked, it was broken. There's even features that look kind of like icebergs, but no direct detections of liquid water. And so we used all of the different instruments on the Galileo spacecraft to basically provide multiple lines of what we call indirect evidence. There were sort of clues that said, okay, maybe there's water, maybe this could lead to water. We had gravity measurements that said there's a layer that's 100 kilometers thick at the surface that has the density of ice or water. But the problem is that those measurements weren't good enough to distinguish between the two. So we didn't know whether it was ice all the way down, or whether it was a thin ice layer and then a water layer, or a thick ice layer and then a small water layer. And it turned out actually to be the magnetic field results, as Jennifer mentioned, that were kind of the best evidence. And this, kind of kills me as a geologist that I want to look at my pictures. But, here were these little wiggly lines from the magnetic field measurements that showed what was really just a beautiful, elegant solution. We detected what's called an induced magnetic field at Europa. And that basically was a signal that could only come from a global conducting layer beneath Europa's surface. And it turns out, if you run the numbers, that salt water, so a salty water ocean with, kind of a salinity, a salt level that's pretty similar to Earth's oceans, actually, that this saltwater layer, if it was global and if it was consistent with that 100 kilometers of ice and water, a pretty big chunk of that had to be liquid. So that was really the best explanation that we had for the signals we saw from the magnetic field, and that's why we think there's an ocean. And so Europa Clipper, 20 years later, it's going to go back, or 30 years later almost by the time it gets there, it's going to go back and it's going to confirm that there's an ocean there, we hope. And we're hoping that the reason radar instrument that Jennifer mentioned will be able to actually see through that ice layer, and it'll be able to look for maybe pockets or lakes of liquid within the ice shell, and maybe it'll even be able to tell us how thick that ice layer is and where the ocean starts. So we're excited.
It's so interesting to hear how some of these instruments will help answer some of your questions that you have too. Now, Tamisha on YouTube asks, what will happen when the mission ends? Will it be deorbited into Jupiter to protect other moons from contamination, or will it be deorbited into somewhere else?
That's a great question. We do deorbit, and as the asker mentioned, the name slips.
Tamish
Mentions it's to protect the environments, right? You don't want to go and introduce a whole bunch of microbes or things like that from Earth, right? Because that would interfere with our signal and our experiments in the future, and that's not considered good form in the science community. And our original plan was to deorbit into Jupiter, but recently, I think over the past year, maybe in a bit, we worked with headquarters and the Planetary Protection Officer and community to change that from deorbiting into Jupiter to going into Ganymede. And the reason we wanted to do that is because we're able to essentially get there with much less work. It actually takes more effort, more time to go from the orbit where we're flying by Europa to actually impacting into Jupiter, and it's much less of an adjustment to go to one of the other moons. And what that lets us do is maximize the amount of time for science, because we need to make sure that we're able to accomplish that end of mission and know that everything on the spacecraft is working properly, and we have very high confidence, again, as a protection for the environments that we're interested in studying.
Great. And I have one last question. It's from Tara on Twitter, who asks, Jennifer and Cynthia, how does it feel to be such amazing champions of women on STEM? You're incredible role models.
Well, thank you.
Thanks.
That's really sweet.
Great.
Yeah, it really does. And one of the cool things about working somewhere like JPL is that we're not alone. There are so many amazing women who work here, who work on the Europa Clipper mission, on all the other missions, all the way up to our Lori Leshin, who's our new JPL lab director. There's amazing women who work here, and it's fantastic to get to work with people like Jennifer and all the rest of them too.
It's really been an evolution and a pleasure. When I first came to JPL, I won't say how long ago, but it was a really long time ago, I was almost always the only woman in the room, right? And over the years, you look around and all of a sudden, many of the folks in key roles, our mission assurance manager is a woman, our director 4, right? So people up the chain. We just had a project manager that was a woman. So our flight system engineers. So they're, we have such great representation now, and I think in particular on Clipper. Yeah. So it's been really a great I guess, progress, you know, that we've really enjoyed watching.
It's really exciting to hear. Even the story how you two met was very cool to find out today. Well, that is unfortunately all the time we have for questions today. Now, Europa Clipper is on track for a launch in 2024. So to learn more about the mission, visit europa.nasa.gov and be sure to check out the 24/7 live cam they'll be running the next several months on the NASA JPL YouTube channel. And we'll keep answering your questions there with a moderated chat every Tuesday at 10 a.m. Pacific time. You can also follow JPL on social media to see the Juno spacecraft images of Europa later this week, which will be very exciting for us all.
Yeah.
And thank you to our guests, and thank you so much for watching.
Thank you.
Thank you.